Hello Math 200 students. This video is going to go through section 1.2. So let's just get at it. Two types of data, qualitative data and quantitative data. Again, chapter 1 is mostly going through concepts and vocabulary of statistics. So qualitative data and quantitative data. Qualitative data consists of attributes, labels, or non-numerical entries. Quantitative data consists of numerical measurements or counts. So qualitative is like, is it good or bad? Is it on or off? Is it green, blue, red, purple? Whereas quantitative data would be like, how much does it weigh? 189 pounds, 190 pounds, 191 pounds. So it's there are numbers involved. All right, so example 1, that's a pretty basic concept. Looking at these two columns of data, one of them is qualitative and the other is quantitative, and I'm sure you can tell this side here is qualitative data. It doesn't involve numbers, it involves categories of cars. Whereas over here we have quantitative data, which is the suggested retail price of those cars. Moving on. Another characteristic of data is its level of measurement. All right, there are 4 levels of measurement: nominal, ordinal, interval, and ratio. And they get more and more specific and exact as you go. So nominal level of measurement are qualitative only. Data at this level are categorized using names, labels, or qualities. No mathematical computations can be made at this level. Data at the ordinal level of measurement are qualitative or quantitative. Data at this level can be arranged in order or ranked, but the differences between data entries are not meaningful. So you can put them in order, but you can't really say how much better number 1 is than number 2 or number 5 than number 6. So you can rank them, but you can't really say how, what the difference is between those ranks. That's the ordinal level of measurement. So let's look at these two examples here. So here in this column here, we have the top 5 grossing movies of 2012. Marvel's The Avengers, The Dark Knight Rises, The Hunger Games, Skyfall, and The Twilight Saga. Whereas in this column we have movie genres. That means categories: action, adventure, comedy, drama, horror. Well, how would you categorize, what level of data measurement are each of these? This one would be what? It's just nominal, because it's not even ranked. Like, you can't say action is above drama or comedy is above horror. It's just naming these things. It's just giving them a name. That's what nominal means. It means name. Okay, so it's not even ranked. You can't even put them in any kind of real order. So this is the nominal level. Like here, I think they're in alphabetical order, but that's not a meaningful order according to anything about what the actual concept of action or adventure or comedy is. This section is putting these things in an order. It's ranking them according to how much money they grossed at the movies that year. So that would be what level? That would be the ordinal level. Ordinal means order. It means put something in order. So these can be put in order, but you can't, it doesn't tell us any figures, so you can't take the difference and say, well, Marvel, the Avengers, made this much more than Dark Knight. So you can't say what the difference is. You can just say it made more, but you can't say how much more. So we get to the next 2 levels of data measurement, and you can tell much more about them. We have the interval level of measurement, which can be ordered like ordinal, but you can also have meaningful differences between the data. Meaningful differences between the data can be calculated. At the interval level, a 0 entry I'm going to talk about that in a minute. I'm not going to read that sentence yet. Data at the ratio level of measurement is the exact same as interval level with one small difference. So let's read it. They are similar to data at the interval level with the added property that a zero entry is an inherent zero. So for the this is kind of confusing. The interval level does not have a true zero. It doesn't have like an inherent zero that actually means nothing. The zero doesn't mean none. So like, whereas the ratio level, zero truly does mean none of something or nothing, or it means zero quantity of that thing, of some thing that exists. So the interval level, an example would be like the Fahrenheit or Celsius scale of temperature. 0 degrees Fahrenheit or even 0 degrees Celsius does not mean there is zero heat. It's just a number on a scale. But it doesn't mean that there is none of whatever it's measuring. It's just a number on the scale. Whereas the Kelvin scale of measurement, in Kelvin scale, the zero on Kelvin truly means absolute zero. That's why it's called absolute zero in Kelvin, because it means zero heat present. So let's think more about that. Here's another thing what that does for us is a ratio of two data entries. When you do have a true zero, a ratio can be formed so that one data entry can be meaningfully expressed as a multiple of another. So at the interval level, you can take the differences, and that means something, but you can't take the ratio. Like that ratio doesn't mean what it looks like it means. Like 100 degrees Fahrenheit versus 50 degrees Fahrenheit. If you do the ratio 100 to 50, that's a ratio of 2 to 1. That doesn't mean that 100 degrees Fahrenheit means that there's twice as much heat as there is for 50 degrees Fahrenheit, because zero isn't a true zero. For Kelvin, it does. For dollars, it gives an example here for dollars. If you're talking about dollars, $0 truly means you have zero money. So you can do the ratio level. So if you have $10 and somebody else has $5, then you have twice as much money as they do. All right, let's look at this example. Two data sets are shown at the left. Which data set consists of data in the interval level and which one is at the ratio level? So here are the New York Yankees World Series victories, the year that it happened. Here are the number of home runs by different teams. One of these is the interval level and the other is the ratio level. Can you determine which one? The years that the Yankees won the World Series is at the interval level, not the ratio level, and here's why. Because the year 0 does not mean no years have passed by. The year 0 is actually, we have BC and AD, before Christ and Ante Domini, so that means year 0 doesn't mean no years have passed by. It just means an event happened that marks history, where there is everything before that event is measured in negative years, or years measured in years before that event, and the years after means the number of years that have passed by after that event. And so the year 0 doesn't mean no years. So that's why this is at the interval level. It does not have an inherent 0 in those years. Whereas the home runs does have an inherent 0. If there was a 0, it means truly no home runs, none. So that is at the ratio level. Going on to the next page. Here is a helpful way to summarize what these things are. Can you put the data in categories? Can you arrange the data in order? You can put them all in categories, including nominal. Can you arrange them in order? You can with these three, but you can't with nominal because there's no order to it. Can you subtract them? No on nominal and ordinal, but yes on interval and ratio. Can you determine whether one data value is a multiple of another, meaning there's a ratio, a meaningful ratio, that would only be at the ratio level? All right, here are some more. Here's another good helpful chart. You can look at that more whenever you look at your textbook, or you can look at your textbook, by the way, when you are in Math Excel. I'll show you. When you're in Math Excel, you can go to Question Help and click Textbook, and that will bring up the section of your textbook that you are currently working on. In fact, that's what I did to get through this section here. I think that, let's see, is that all for this section? I think it may be. Let me make sure though. Yes, that was all there was to section 1.2. That was very quick and simple. Good luck on that section. I'll see you in 1.3.